How do satellites perform orbital maneuvers? Imagine a satellite floating in space, cruising along its path, when suddenly it needs to change direction or altitude. How does it do that without a pilot or steering wheel? That's where orbital maneuvers come into play. Satellites perform these maneuvers by carefully changing their speed and trajectory using onboard propulsion systems or by taking advantage of gravity. These adjustments help satellites stay in the right spot, move to new orbits, or avoid collisions. The process starts with understanding how objects move in space, which is governed by Newton's laws of motion and gravity, along with Kepler's laws of planetary motion. These laws help predict how a satellite moves and how small changes in speed, called delta V, affect its orbit. To perform a maneuver, mission teams calculate the exact amount of delta V needed to change the satellite's energy. This can mean raising or lowering the satellite's altitude, shifting its tilt, or changing how fast it orbits the Earth. Satellites usually have onboard thrusters powered by chemical or electric propulsion systems. Chemical thrusters give quick, strong pushes, perfect for rapid changes like orbit raising or lowering. Electric propulsion uses low-thrust but continuous burns, which are more efficient for gradual adjustments, especially in low Earth orbit or beyond. These propulsion systems are carefully controlled to ensure precise movements. There are different types of orbital maneuvers. Station keeping involves small tweaks to keep a satellite in its designated position, especially important for satellites in geostationary orbit that need to stay fixed above one point on Earth. Orbit raising or lowering involves increasing or decreasing the satellite's altitude by using two engine burns, called Hohmann transfer orbits. The first burn puts the satellite into an elliptical transfer orbit, and the second burn circularizes the orbit at the new height. Changing the inclination, or tilt, of the orbit requires a lot of energy and is often done with continuous low-thrust propulsion or carefully planned impulsive burns. Phasing maneuvers are used to adjust the satellite's position along its orbit to synchronize with other satellites or meet mission needs. Mission control teams constantly monitor satellite positions using tracking data. They plan maneuvers to optimize fuel use and achieve mission goals. They command the thrusters to fire at specific times and durations, making sure the satellite stays in its desired orbit. These maneuvers also help avoid collisions with space debris and extend the satellite's operational life. In space, natural forces like atmospheric drag, solar radiation pressure, and gravitational influences from the Moon and Sun can slowly change a satellite's orbit over time. Regular orbital maneuvers counteract these effects, keeping the satellite on track. Overall, orbital maneuvers are essential for maintaining satellite functions, managing constellations, and ensuring safe, efficient operations in the challenging environment of space.